Okay. Yep. Good morning, folks. Welcome to the OpenPGP session for IETF 120. My name is Stephen Farrell.
And I'm Daniel Gilmore. We are your co-chairs. So thanks for being here. It's the first session on Monday morning. We are opposite the dispatch session, which may make it a little bit tough for folks who are trying to dispatch things within the IETF.
Or easy.
Or easy, because maybe you're not interested in anything that's going on in dispatch, but we're glad you're here. And we have a decent agenda with a number of things adopted. I think we're going to go through, this is the first session. If you're new to the IETF and you have not read the note well, we recommend that you read the note well. Apologies that this is kind of an eye chart here. You may prefer to read it on your local device. It should be linked to from the agenda. Basically, if you have IPR in this discussion, we expect you as a participant to disclose it. We expect you to, you should acknowledge that your participation here is likely to be recorded, and there will be recordings published. We will not try to take pictures of anybody who's not speaking at the mic, but it's hard to control that with the cameras the way they are. And yeah, be good to each other here. Next slide here. Thanks for driving. A reminder here, this is a hybrid meeting. At least half of us are remote and half of us are in person. So please try to make sure that you have signed in. If you're present here in person, there's a QR code in the back of the room. If you're remote, please stay on mute without the video running unless you're speaking. Join the queue if you need to speak. Even if you're in the room, please join the queue. That will actually help us to track who has come up. We'll manage the queue from here. If you can't figure out how to join the queue, you can ask your neighbor, but it's from the Meet Echo client in your browser. Next slide here. One more reminder about being good to each other. We have technical disagreements in this community all the time, not just within OpenPGP, but at the IETF generally, but we try to make them not into personal disagreements. Not everyone here speaks the same set of languages, although we do try to communicate in English. If someone speaks too fast, you can ask them to slow down. If you find yourself speaking too fast, try to slow down before someone asks you. And we are just going to try to work together well here, even though there are some ongoing disagreements and disputes. Next slide. We have stickers. The IETF produces logos for some of their protocols, and OpenPGP is one of them. We have stickers here at the front of the room. If you are an IETF OpenPGP enthusiast or you know any and you want some stickers, come find me or Stephen either at the end of the session or later around the meeting. If you are not physically present, I have a bunch of stickers and I can send them. To you. If you let me know where you want me to send them. Next. So our basic agenda for today, we'll have a brief discussion, comment about where the crypto refresh draft is. That's the revision to RFC 4880, which has been the major course of work for this working group since it was finally reformed. We will get a report back on the OpenPGP email summit from Patrick Brunswig, who is one of the organizers of it. We'll have a presentation about the post-quantum cryptography work. And then we have some discussion about persistent symmetric keys and the replacement key draft, which are these are three drafts that we currently have chartered in the working group. And if there's time, we might have a little bit of discussion about a potential new draft, which is salts for V4 signatures. If anybody has any suggestions for how to bash this agenda around and make it better, now is a good time to talk about it. Otherwise, we can go forward. Falco, I see you in the queue.
Yeah, I just have this one question. We have this new draft about breakpool and NIST curves with PQC. Will it be in the PQC slot or will it be an extra slot? How will we? Because it's two different presentations, two different drafts. we are also not, our draft is also formally not adopted because we split it out from the existing one that is adopted. So I think formally it has to be adopted.
Yeah, I think we should put those two together, and y'all can decide which order they go in, if that works for you.
Yeah, that's good. Then I suggest first the existing adopted one, the OpenPGP draft, OpenPQC, OpenPGP, and then the NIST brainpool.
That sounds good to me.
Okay,
Thanks for that
thank you.
clarification.
No other agenda bashing?
Okay. So a brief report back on the crypto refresh. It is in auth 48, which is the final stage before the RFC editor turns it into an RFC, the final stage. And as of in auth 48, the authors all need to approve the set of changes that were and cleanup that was done by the RFC editor. This is one of the largest sets of changes and one of the largest documents that we have dealt with. It's probably not the largest, but it was quite an intensive auth 48 process. But as of Saturday, all the authors have approved, and it will be RFC 9580. It is not done yet. I was hoping to be able to say, we have an RFC today, but it was done on the weekend. We'll see what we can get done. Maybe by the end of this meeting, by the end of the week, we'll have it. So that is good news. We are in good shape here. Yeah, next one's good. So just a note here about interoperability. We have 3 adopted drafts. And so as these drafts come up and as we're discussing them, we're going to want to hear if you're implementing or if you're reviewing it. We're going to want to hear if you have ideas for test vectors or the interoperability test suite, which is out there. So just something to keep in mind. You know, we are an implementers community. We're trying to make things that work for people, and we want any reports you have that you think other people in the group might not know about what you're doing towards any of these adopted drafts or towards what will be soon RFC 9580. You know, we'd love to hear about that. So as those come up, you know, don't be shy about raising those concerns. That's for the final one. Okay. We're going to turn it over now to, I believe, Kwon. Are you going to give the OpenPGP PQC?
No, the report out from the.
Oh, sorry, Patrick first. Yeah, thank you.
So Patrick, I'll share the slides and I'll give you control of those. So 1 second. Okay. So Patrick, you should be able to go backwards and forwards and.
Yes. Okay.
And maybe briefly introduce yourself, since I think. This is
yeah, sure. Yeah. Hello, everyone. I'm Patrick Brunswick. I've been working on Enigmail since 2003. Enigmail used to be a plugin for Thunderbird. I'm still maintaining it for a couple of forks of Thunderbird, like Postbox, CMonkey still exists, and Epirus. In my professional life, I'm value stream product owner at the Swiss bank. Yeah, we've started with these OpenPGP email summits a few years ago to bring together the various communities or sub-communities, like those who implement email clients or plugins like Proton, Thunderbird, R2Mail2, Delta Chat, Plank, or PEP. We also have people from Contact and Mavelop. Usually they couldn't come this time. We have people from OpenPGP implementation or libraries like Sequoia, OpenPGP.js, RPGP, GoPGP, or RMP. In the past, also GNU-PG joined the sessions. We have supporters from key servers like HockeyPuck and Hagrid. In the past, also Christian Fiskestrand from SKS key servers joined frequently. And many of us also work on standardization like OpenPGP version 6, PQC, LAMPS, AutoCrypt, and many more. So the idea is really to bring together the various parties to have an open discussion and find common agreements, and also just to get to know each other. It's been the 8th summit since 2015. It's usually yearly, but we had a break during COVID. The way we work is an unconference style. That is, the agenda is fully driven by the participants, and you can see on the picture the topics that people brought up. It's a bit more than we manage to discuss. Usually, the way is really that we bring up the topics and then we vote which topics we want to present or discuss. We have 2 or 3 breakout rooms where we can talk in smaller groups, and we usually also have plenary sessions with topics of more general interest. And what is important to me, we also have a joint dinner or 2 joint dinners, so a social part where we can just get to know each other and really turn into a community. What did we discuss? We usually start with what has happened since the last summit. So everyone who had a to-do since the last summit gives a quick report back. We usually have a ratio of 60 to 80% of achievement, so that's quite good, I'd say. So this time we started, well, quite obviously with the schism between OpenPGP and LibrePGP. Many people, also neutral people, tried to talk to Werner without success. And my fear was that it would be a hot topic during the whole summit. But it turned out, and this was the good thing, that we had the schism at first, that after the session, it was a general consensus that the schism is there and we can't fix it for the time being. And we could put it aside and talk about the real topics that we had. We also found that GNU-PG is not that important anymore in the world of OpenPGP email, because many email clients moved away from OpenPGP, from GNU-PG, or those email clients that use still GNU-PG are not those that are used the most frequently. Then we had a first session about PQC in OpenPGP version 4. The idea was that this could have a quicker time to market than version 6. However, it's not specified and would add a lot more complexity. Furthermore, we found out that PQC in version 4 would only be available for encryption, but not for signing. And version 4 PQC subkeys would be more fragile than shipping a full version 6 PQC key. In the end, we didn't come to a real consensus about that. Then we had a session about header protection, so protecting the subject and other headers inside the encrypted mail body. DKG presented the current status of the draft. It got more and more complex. Basically, each time DKG presents it, it turns more and more complex, mostly because it's difficult with legacy email clients that don't support the feature, and therefore it's getting really difficult to implement that. Then we had a session about forward compatibility, so how to deal with things that aren't specified yet. So how should v4 behave when it comes to a v6 key, but also how should v6 behave if a PQC subkey would be detected. The consensus was that there is no real general consensus. It highly depends on the use case of the mail client or the user, basically. It seems feasible to have some forward compatibility for certificates, like ignoring certificates that you don't understand. But when it comes to private keys, it's very difficult to have anything. Then we had a session about HKP and WKD. And the session was mostly about designing a new version of the WKD protocol or API. We would probably not call it WKD anymore, just to be not in conflict with Werner. And we came to the conclusion that we would try to keep the changes as minimum as possible, but still that we should allow some redirection of WKD to HKP. The next session was about key distribution methods. we collected the various methods for key distribution, and we counted a total of 9 methods, like AutoCrypt, key servers, WKD, and so on. All of them have their advantages and disadvantages, and actually the conclusion was to overcome all these advantages and disadvantages, we should maybe invent a new key distribution method, but this is like adding a 10th, so not really an option either. Then migration to OpenPGP version 6 was certainly the largest or most important of all topics, and I'll come to that in the next session, on the next slide. Then also this is a topic that Andrew will present in more depth. We had then a session about automatic encryption to published keys. Mainly Proton tried to turn on the lookup of keys on keys.openpgp.org to automatically encrypt to people who have published keys. It generated, unfortunately, a lot of complaints and bad press because people all of a sudden received unencrypted mails that they couldn't decrypt. So it seems that there is an expectation mismatch regarding what uploading a key to a key server actually means. There was no conclusion. It seems that this topic is again depending on the use case and the implementation. The last session was about how to initiate work on AutoCrypt 2.0. We first discussed the topics, so what could be the first things that we would implement in AutoCrypt 2.0, and we tried to find out who would be interested in working on it. There was no real conclusion apart from, let's start and do something again. Finally, I'll present a little deep dive into migration and to certificate migration from version 4 to version 6. The idea of the session was that we would try to overcome the period when both version 4 and version 6 are alive, but not all implementations already support version 6, and what to do with that. Adoption can be quite slow because people have long-living version 4 keys. I mean, some people create keys with a lifespan of 10 years. So that's quite something that we have to foresee. And people also are sometimes reluctant on upgrading their mail clients and stick to old libraries. We found out that much of the adoption is actually needs to be handled in the mail user agent and not in the OpenPGP library. Of course, the OpenPGP library needs to support whatever we specify, but the actual work needs to be done in the mail client. It's obvious, but version 6 can only be used if all participants in a conversation have a version 6 key. Otherwise, you either need to have separate encryption, or you need to fall back to version 4. So we discussed the idea of linking keys, and that shouldn't only be specific for version 4 to version 6, but we should also allow to work to migrate to PQC at a later stage. The idea is that the linking of keys should be done in a way that it allows for automatic processing by the mail user agent. We found out that it should be equivalent to assigning sub-key binding from a cryptographic and user experience point of view. We discussed whether UIDs should be linked or whether just the keys should be linked, but we couldn't find an agreement. It seems to depend on the use case. For instance, AutoCrypt declares the user ID decorative, so you could use anything. And for version 6 also, user IDs are optional. Therefore, there was no real conclusion on that. We had a lengthy discussion on whether we should allow chains or trees and possibly loops for this linking, and we came to the conclusion that all of that would be far too complicated. So the idea is that we disallow chains and trees for simplicity simply, and that is, If you create a second link to another key, you by definition you drop the link that you created before. The direction of the linking needs to be a preference that the user sets. So you could also link, you can link a version 4 key to a version 6 key and say, I want to migrate to version 6, but you could in theory also do the opposite if you'd like to. Then we discussed how the sender mail user agent could migrate to version 6. So the idea is that the mail user agent links a version 4 and version 6 key and publishes both of them with whatever mechanism the mail client uses to publish keys like HKP, WKD, AutoCrypt, whatever it is. The idea is that when you send a mail, you sign it with both keys and ideally with the fallback key, so the version 4 key first and the version 6 key later, second, so that a library that doesn't understand the version 6 key can verify the version 4 signature. We discussed about aborting the migration, and the idea is you simply revoke the new key and you're basically done. Once you're completely at version 6, the cleanup, so the full migration would be that you revoke the old key and also the link. And how should the sender migrate to version 6? The idea is that if you cannot verify the linkage, so if you can't fetch the new key, for instance, you simply ignore the linkage. If you can verify the linkage, you encrypt to the preferred key first, and if that's not possible for you, you encrypt to the fallback key. This way we found a mechanism that allows to link keys and still be able to use either of them individually. As I said, Andrew will present a draft for exactly this later, and that's about it. So this is basically a brief summary of the summit. Any questions?
Thank you, Patrick. While we're waiting for questions, let me just ask you to mention if we have, is there another summit coming up, and who would be welcome at the summit?
Sure, I'm planning a next summit, April next year. Basically, anybody is invited, especially those who work on implementing either a mail user agent, an OpenPGP library, standardization, key server, and so on. Please join us. I usually publish everything. There's a mailing list where I publish everything, and I'll also send an invitation to the IETF working group.
Thank you. I don't see anyone joining the queue right now, so I think we'll move to the next session, but thank you for presenting that.
Yeah, thanks, Patrick. I mean, I think it's also worth pointing out that I mean, I kind of like the interaction between the kind of developers meeting in the summit and that feeding back into changes to the proposed drafts that we've been adopting. I think that seems like a good modus operandi to me anyway. So thanks. And thanks for hosting it.
Yeah, very productive meeting.
Thanks.
Thank you, Patrick.
Okay. And so we're on PQC.
Does this clicker work for you?
No. Who's presenting this?
Hello.
Aaron, you're up, are you?
Yep, I'm here. Can you hear me?
Control of the slides?
Yep, seems like it's working. Okay, so this is going to be a brief update of what has happened since the interim meeting 2 months ago. So we've done some changes to the draft. We fixed the MLDSA signature size that was wrong in the IPT. We did some minor fixes around with parameter orders that were in the wrong place or were missing. And the major change that probably we've done is to change the parallel encryption guidance. that was a very old issue. This means when you have two recipients that you don't want to encrypt to the same recipient, both in PQC and traditional way, how to avoid this. And it's now basically up to the overlaying implementation to choose whether they can do it at all or whether they can't. And then we added some ML DSA test factors. I announced this because as of a few days ago, also OpenPGP.js implemented ML DSA. And therefore, we were able to generate them with GoCrypto and verify them in OpenPGP.js. This is the current implementation status. So GoCrypto is probably the one that is the closest to completion. That has only SLH DSA that is still the round 3 submission because we don't have a library that does SLH DSA as IPD. OpenPGP.js also implements MLChem and MLDSA, but just in the 67 variant and the 768. RMP implements only MLChem IPD, and also it doesn't implement completely the V6 standard. Please also, FICO, keep me honest. If I'm saying anything, jump in the queue and correct it. libgcrypt instead seems to be implementing all the algorithms, but is not upstreamed, and since GNU-PG we know is not really friends with V6, it's having issues there. Therefore, the only test factors we could reliably test and generate were the ones with MLChem and MLDSA. We have a few changes that we would like to present and try to get in before IETF 121. And these are a bit more substantial changes, as well as like the issue that was being presented before about whether to bind to V6 or not. But let's start with the key derivation and combination. We, as announced at the interim meeting, we're still using a provisional version of the CAM combiner. This means it's explicitly noted as it might change. It's not a huge change code-wise, but it will probably be a breaking change. And as soon as we manage to settle the NIST compliance, and the CFRG maybe has come out with, the working group has come out with an idea, maybe we'll fix it. We'll fix that. Mike, since next slide is about binding encryption, maybe it's best if you come to the mic now.
So, yeah, this is going to come up in labs also. This is a shared issue. My question for the OpenPGP community is, do you want to wait for CFRG? CFRG may take a year or more to decide what it's going to do about chems, hybrid chems. Does OpenPGP need to move faster than that, or are you happy to wait?
I would be happy to move faster than that. Like, if the outcome is to take years, I would like to move faster. I don't know whether the whole working group would like to move faster, but at least from my perspective is, I think we can afford to wait till we have other issues that are open that we don't have consensus on and stuff like this. Personally, I think it's nice to have a CAM combiner that is shared across implementations and so on, but literally we're talking about, at least in Go, something like 20 lines of code. So it's not that even having a different one will greatly impact our implementation size or anything like that.
I tend to agree with that. I mean, I think we need this faster than it's going to be delivered from CFRG. That said, I think we should make this decision intentionally rather than by accident. The timing issue, the interop between protocols issue, one crypto library that will work across protocols, and the security analysis are all, I think, important considerations here.
Yeah, we have our own security analysis in the draft, and I think that we've managed to get something so far without CFRG. I will also say this at the CFRG session, that is basically, we can't afford to wait forever. to have a result. I was also in the working group of the CFRG, so I've seen what was going on there. So yeah, Quinn.
I'm Quinn Deng at NIST. I personally like to push things forward faster. However, there is a good possibility that after the CFRG has some endorsement on some specific CAM combiner, one or more, I don't know for sure right now. But at that time, that could be possible that one of the CAM combiners that the CFRG endorses or specifies could also be compliant with NIST, and then that would be perfect for everybody.
Yeah.
So there's some pro for be patient a little bit more, but at the same time, I want things to move fast. But there is potential good benefit for being patient.
I see. So I think we have. I wasn't to give a brief recap of what happened in CFRG. I think there seems to be an idea to standardize some CAM combiners with a draft that is partly generic, so offers a generic way to combine any two CAMs, maintaining the security properties, as well as some specific instances. And I don't think the specific instances would already cover X448, for instance. So we already go out of the specific instances, and we would need to implement the generic version, most likely. And said this, there is clearly we all agreed in the working group that there is the, let's say, dump version of the CAM combiner that is pretty much put everything in it, and that will be safe. The problem is the fact that that is very little efficient. OpenPGP, at least in my opinion, is not really an efficient protocol in the first place. It's not like, it doesn't need to be like TLS. So we might also live with a very explicit CAM combiner that gives us the safety properties we want. But that's like, as I said, I don't want to put ourselves ahead of the problem. I would first like to see what happens in CFRG before having to take this decision. Regarding the NIST compliance.
Sorry, Aaron, just on that. I mean, I think maybe not everybody's familiar with CFRG. So one thing is CFRG does not produce standards. I think you said it might be standardizing something. It's a research group that doesn't do that.
Yeah.
And secondly, so CFRG is the Crypto Forum Research Group. A bunch of people, including Aaron, myself, and Mike, were involved in a design team to see what should CFRG do about requirements for CAMs. That will be discussed later this week. And CFRG then, if it follows the outcome of that design team, might then produce specifications for some CAMs that could be used by OpenPGP. And I think to answer Mike's original question, or to comment on Mike's original question, I guess we should be aware of at what point in time do we want to fix the CAM that's used by OpenPGP. And that point in time might be before the CAM combiner. So yeah, at that point in time, maybe before CFRG has finished, or maybe CFRG's work will be far enough along that we can just kind of adopt it. I don't think we'll know for a while, but the time to make that decision is not right now. It's a little bit down the road, I think.
It is down the road, but let me just also comment that we have not designed this to be a generic CHEM combiner, right? We have one code point that says use this CHEM combiner with these two chems.
Right.
And just because we choose one, if we decide to standardize one before CFRG gives its blessing, and we find out that they gave a blessing to one that is not the one that we chose, it is possible for us as the OpenPGP working group to define another code point that says use this other CHEM combiner. So we're not picking a generic combiner that's going to necessarily sit with us for every future pair of chems. Just remind me there.
Mike? Go ahead, Mike.
Yeah, I like this. I think this to me seems like the right direction. I strongly second both Stephen and DKG. because yeah, it's where you're registering code points for pairs of things, and if it comes out later that the research says, oh, we also need to bind some other ASCII art to protect this other attack, you know, we can spin this again, right? There's nothing preventing that. So that seems right. Is move fast with what we think is correct now, and if it turns out that it's not right, or we want to synchronize it with other groups later, do that later.
There's also a last point about the NIST compliance is the fact that we do not, in this draft right now, we do not have a NIST approved curve. So the NIST compliance of the CAM combiner also, it can be considered shaky because whether we want it at all. This, I think, this point applies definitely to the next presentation when we'll talk about NIST and NIST curves. The curve 25519 is NIST approved, but in the ED version, not in the X version, as far as I know. I see this question in the chat. It's fascinating how CAM combiners can always bring everyone to a discussion. Can I move to the next topic?
Please.
Okay. Okay, so binding encryption to keys to v6. This means that an encryption, yes means an encryption key can only, a PQC encryption key can only be v6. No means it can be v4 or v6. We don't talk about v3, v5, or anything of that sort. We had a thread on the mailing list, and I tried to recap a little in one slide the opinions I've seen there. And basically, we're like, not all implementations are ready yet for v6, and clearly against because it's we would guarantee a quicker deploy. So it means that many implementations are ready to just implement PQC straight off with the v4 battle tested implementation. But some people presented the fact that it's more difficult to ensure backwards compatibility because this means that some implementations may choke on finding unknown algorithms or just the size of keys. It might hinder the adoption of v6 because some people might just say, well, I have PQC encryption on v4, why do I need v6? And then it limits the combinations. If we bind it to v6, we have less implementation, less combinations that we need to cater to, less test vectors, less complexity. We had this discussion at the last interim as well, and there was a new no point, that is LibrePGP allows v5 PQC subkeys, but they can be attached to v4 primary keys. So they have a binding, but they do not have the binding towards primary and sub keys. So that also opens a new whole can of worms that we don't want to touch. Again, there was some people arguing for reducing the complexity and holding back the v6 migration. This discussion happened all over, again, at the OpenPGP Meta Summit, where Patrick before told us about it, and honestly, we haven't reached a consensus there either. Arguments are very similar, less work, and the implementations are maybe not be ready to have v6, but it boiled down to be mostly RNP, being not v6 compatible, and this implementation seems to be considering implementing v6 anyway, and has a partial implementation of v6 made from Johannes. Now, there is a new argument for the yes, that is that only one migration will be necessary. So you can bundle up the two migration to v6 and to PQC into one single bundle and just deliver that. This is true technically also without a binding, but it makes it easier to sell. So this is what we came up with in the end among the authors. That is, the current draft has test vectors for encryption with v4, so it's definitely allowed. It's, I would say, the main thing we've been testing so far. But as of the latest draft, we also offer v6 vectors with PQC. And so this may change. there is a clear consensus on allowing PQC using SEIPD v1. This means no matter whether it's v4 or v6, you will be able to communicate with mixed recipients using PQC and non-PQC. This is something that is where there's already everyone seems to be agreeing, so at least this is not the problem. There are slightly more people preferring a binding to v6, counting the number of voices, but this is not really a consensus. And the people opposing the binding said they would accept the binding if there were a clear v6 support and a clear migration strategy. So the decision as authors of our proposal is to consider an increasing support for v6 in the next draft, coming approximately halfway between now and the next IETF. We would like to plan the binding to v6. In case you disagree with this statement, please scream at me now. Scream at me on the mailing list, or scream at us on the mailing list, and we won't do that pretty much. So. That's it. We have a nice graph, nice little thingy at the end where you can click on our issues if in case you're interested into looking at more boring issues that we have on the data tracker, on the issue tracker.
So I think Mike raised a question in the chat that's probably worth taking at this point.
Okay.
I don't know if you want to join the queue and say it out loud, Mike, or?
Okay, I'll read it out loud. Is the OpenPGP working group ready to assign a milestone for publishing the PQC RFC? Generally, are we thinking within 1 month of the final FIPS draft, or by 2027 would be fine? Personally, I think that having such a strict deadline, such as within 1 month of FIPS standards, is even not possible. We also have other issues open, such as this one. If I could, since next IETF is close to Christmas, if I could make a wish, is that we would be ready by then, but this is clearly wishful thinking. The thing is, also I think that by 2027 is a little bit late. Some funding is gonna end at the end of the year or early next year. For MTG, the other authors of the draft, and it would be nice if by the end of this year we have something that looks sort of stable. Changing a KDF is not a big breaking. It's not a big change, but it's still a breaking change. It would require updating all the implementations, all the test vectors, and everything.
So what was the summary?
What's the answer to this?
Aaron, what was the
answer? The answer in too long didn't read is, it would be nice if by the end of this year we had something stable, but this is not up to us. It's up to the working group to decide.
Yeah, but I mean, it's useful to know what goals people would like, because they're milestones. Yeah. They're mostly fictional, so but it's kind of useful to have a target. So the author group were kind of, for the moment, kind of suggesting that aiming for this work to be stable by the end of this year is a goal.
Yeah,
I think that's optimistic, but okay.
Yeah, you gotta be. If not, we don't go anywhere.
I like optimism.
Sure.
Yeah.
Okay. Any other questions about the PQC drafts? If not, I think we move to Quinn.
Yep.
Okay. Let me just get your slides up.
Join us here on the pink X.
I don't think you have to stay there anymore, but
I don't have to say.
I don't know. I think the mic. You can.
We'll see what happens.
You can test it by walking around the room if you want to try and test it, but I don't know.
There's 2 cameras in the room, and one of them is focused on the chairs. maybe Echo can point the camera towards the speaker.
No, I think that happens automatically as he speaks.
Okay.
Hello.
So I don't know.
That's okay. I'm Quinn Dang at NIST.
Say next.
I'll message.
Since
No, no,
the last meeting,
I think it'll just happen.
the working group decided to have a new draft which specifies the MLChem, MLDSA with the NIST curves and with the brain pool curves. Based on the interest and the decision from the working group that's only specifying hybrid chems and hybrid signatures with post-quantum algorithms for now. So that's why in this draft, we have only hybrid modes for chems and for signatures. How can I move to
Shall
next
I-
slide?
We have
Oh,
a clicker,
next slide,
but
please.
yeah, just
The clicker doesn't work.
Yeah, here is the draft location, and we have the GitHub location as well for the discussions and the comments on all the material related to the draft. Just be brief and go to the main points that we want to discuss in this meeting. For the hybrid chems, we for the NIST curves, we are having 3 options. The first one is we go with the MLChem level 1 with NIST P256, and the MLChem level 3 we goes with the P384, and also for level 5 we use P384 as well. And for the signatures, the hybrid signatures, for the level 1, level 2 MLDSA, we use this P256, and level 3 we use this P384, and level 5 we goes with P384 as well. The reason for using the P384 for level 3 and level 5 is that P384 is kind of more widely available instead of the P521. It's not really been used much. So to make the adoption a lot easier and to push the post-quantum security out there faster and better, we are comfortable with P384 to be used in the other options beside the level 1 security option. And P384 is pretty good, and P521 to me is overkill. So that's the reason for the 3 options for each from a NIST curve. From the brain pool curve, my co-authors, they do have 2 options for each. And the first one is they go with MLChem 768 with the brain pool curve 256, and the level 5, the 1024 chem, they use the brain pool curve 384. And similarly, for the signatures, they go with the level 3 MLDSA with the brain pool curve 256, and the level 5, they goes with the brain pool curve 384. And yep, that's what we currently have in this draft. Next slide, please. We basically follow the main draft to discuss things and specify things in the draft. And currently the chem combiner is basically equal to the chem combiner in the original draft. That we think that there would be some changes in the future, but we don't know for sure what needs to be changed yet, and that needs to be discussed and synced with the main draft or not. So that's why we decided not making any huge changes right now with the CAM combiner in the draft because we don't know exactly what is the best thing to do. Next slide, please. Yeah, we have some questions for the working group, and 3 main points are here. Eventually, we would like approval and get code points for these options in the draft so that people could use post-quantum for OpenPGP. And about the CAM combiner, a similar question like we had in the previous talk. How should we go from here for the CAM combiner, for the KDF? Yeah, we certainly one point I would like to make it clear here that from the previous draft, actually even in the case we don't have X25519 Diffie-Hellman or the X448 Diffie-Hellman, they're not currently NIST approved, but with MLCAM is approved, you can get certified for post-quantum security for your solutions. If you would like to have NIST certified or FIPS approved for your system. So you don't need both of them to be NIST approved to be able to have post-quantum security solutions in the NIST approved mode. So that's why the CAM combiner is relevant and important in both cases. Next slide. I'm sorry, I talked ahead of my slides. Yeah, and I will have to have the group with the direction, with the guidance from the group, and to help with the key combiner KDF moving along. And I will point out and I will give my assessment to the structure of the KDF that we have in the future, whether or not it is NIST approved or not, and what needs to be changes if needed. So I will be go along with this and helping the working group, making sure to achieve the goal. If the goal is to get a NIST compliance KDF and hybrid CAM or hybrid signatures. And also one more thing, we are using the pre-hash version of the MLDSA in this draft, and also potentially we will do something with the hash-based signature Spring Plus. It's called SLH DSS. We plan to use propose to the working group using the pre-hash variants. And also we for the a little editorial term, we would like to make sure that the hash value goes into the signing function. We're not calling that a message anymore if we consider the pre-hash at the step altogether. So we just call the hash is the hash, the message is the message. We're not calling it the hash of the message is the message. To be less confusion, I guess.
So part of that has to do with the history of OpenPGP, right? You're referring to the fact that there's the OpenPGP signature process, which involves hashing the message, right? And you're saying that with this draft, you're not doing an OpenPGP signature. The OpenPGP signature process generally is you have the message, and then it's hashed, and then the hash is fed into the signature into the signature scheme. And are you saying that with this proposal, you're changing that behavior in OpenPGP?
No, I think it's just called using a different term to be more clear. But I think that's called the pre-hash, and that we apply.
Okay, and so are you binding this particular signature scheme to a digest scheme, a digest algorithm? Like each signature code point has a specific digest that it uses?
Hey, Falco, are you here?
Yep, it's coming.
Yeah, I think we have to check that. That was, I think, specified in the main draft, but we might not have taken that over. Maybe there's still a gap. I'm not sure. We will check that.
Okay.
Yeah, and one thing this is important to this as well. In the MLDSA FIPS that we're having, for the pre-hash function signing, we actually include the pre-hash function step as a formal step inside the signing function. So basically, having formally two different signing functions. One signing function is for the normal pure signature, and the pre-hash signing, which includes inside the pre-hash step.
Okay.
So that means, yeah, you have two different signatures.
Yeah, maybe if I may add, so this is just on this, we put it on the slide because in the crypto refresh, it is already actually misinterpreted for the CFRG curves. So the pure @DSA is used where the hash @DSA should have been used. This doesn't matter because in OpenPGP, we're always hashing the signature algorithm ID. So there cannot be any mix-up, even if later the other variant, the correct variant would be added, there would be no problem, no security problem. But the idea is if you pre-hash like it is done in OpenPGP, that then you use the hash variant, and what you input into your signature function is h of m, so the hash of m. And in the crypto refresh, there's a reinterpretation. So this is just here, we mentioned it to clarify that this will be a bit different so that people are not surprised when they read it and compare it to the crypto refresh. But it's really a minor point, actually. It's not really important. It's absolutely compliant with conforming with the way OpenPGP functions.
Daniel, I see you in the queue.
Yeah, at the risk of derailing this whole conversation about this indeed minor point, but I believe that the pure EDDSA of a message, the pure EDDSA of a hash of a message is not the same as the hash EDDSA of the message, right? Because there are some like variant specific context in the RFC that like separates them, as far as I know. So I think for the crypto refresh, it is important which one we specify, in the sense that, I mean, the thing that everybody implements is using the normal EDDSA function, not the pre-hashed one, and then feeding the hash of the message into that as the EDDSA message, right? I don't think we can reinterpret that in the crypto refresh as using hash EDDSA on the message.
I'm not sure what, but
I'm going to suggest we take this to a mailing list
Yeah.
because it requires people to go back and look at the CFRG's mistake in defining two APIs for the same thing from years ago. So maybe we'll take that to the mailing list if there's discussion about how to use, whether to use pure or hashed APIs in post-quantum signatures. That's probably a good topic as a thread on the mailing list.
Very good. I think that's the last slide.
That's the last slide.
Yep.
So I think the question, at what point do you want to suggest bringing this draft for adoption, or is that now, or is that in the next revision, or what's your ideas?
I have not discussed this with my co-authors. Fogo and others, would you like to ask for formal adoption now, or would you like to take a look at the draft and then ask for adoption later? I'm not sure what
I think we're ready to call for adoption now. So in my view, we can ask for adoption because it's only at most minor things that need to be corrected. All in all, it's just a fork of the main draft We split off the combinations with the NIST and brainpool curves. We added one code point for NIST,
Sure.
and otherwise we're not intending to make any changes.
Okay, so yeah, I mean, I'm guessing people haven't read
We
this,
didn't.
so we can give
Yeah.
them time to read it. Just to be clear, then, if the working group decided to adopt this in a while, the questions that are shown on screen here now would be decided by the working group, correct?
Yes.
Yes.
Yep.
Just for context, when we discuss adopting this, at that point, the working group will be discussing must versus may and so on, as usual.
I'm serving the working group desire.
Yeah, exactly. Yeah, I just want to make that clear to people.
Yep, understood.
Okay, so I think the action here is probably give people a little bit of time to read it, and then the chairs will have a look and see when seems like a reasonable time to issue a call for adoption.
Yeah. That sounds perfect. Yeah, I don't want people to vote on something they don't know for sure yet.
Yeah, so we'll give it a bit of time, and in a while we'll consider a call for adoption.
Awesome. Thank you.
All right. Thank you.
Thank you.
Okay.
Sorry, before you walk away.
Well,
I do have. Yeah, I will ask the main question here, which is, like, do we really need it, or like, what's the concrete motivation? Because in my mind, the non-quantum algorithms are purely there as a fallback, right? And we had, as Quinn mentioned, the combination of MLChem and X25519 with a NIST-approved chem combiner can be considered approved, as far as I understood. So, is there really a need to also define MLChem combined with the NIST curves and/or the brainpool curves as well?
Oh, that's a good question. Yeah, that is a good question. My guess is that there are a lot of places people have a NIST curve, and they might not have the X2519 or X448. And if those people, they personally desire to have a hedge with the new post-quantum by using the hybrid mode, then this draft would give them those options. So I think, yeah, maybe on the web, more X2519 Diffie-Hellman than the P256, but there are a ton of P56 traffic. And for a lot of people who would like or need to be NIST compliance or FIPS approved, then they have P56, and they need to be able to use that for the hedge benefits if that's what they want to do. So I think both drafts have their strong purposes to serve, and we fine with either poor post-quantum or the hedge, the hybrid modes. We're happy with both, and people we don't have any reason to not happy people who want the hybrid mode, and both draft would be fine to serve their own purposes.
Thanks. Yeah, I mean, just from my personal view, X25519 is already quite widely deployed in OpenPGP implementations. So I think for most implementations that are implementing PQC, that shouldn't be a concern. But I mean, obviously, if someone disagrees, feel free to speak up.
Yeah, another of my purposes is that I promote good secure crypto deployments and solutions. So the more good solutions we have available for people, that's the better. That's my goal.
Falco,
Yeah, well, I think.
Yeah.
I think there is a downside as well, though, in terms of like the number of algorithms and combinations that we need to test and so on, right? So that's kind of the reason why I'm asking.
I'll go.
Yeah. So I cannot speak for the BSI, and unfortunately, no one from the BSI is here today. But it is just a fact that the brain pool curves are the only curves that are approved for governmental applications, and yeah, this has a wider impact, of course, in Germany and maybe also in other European countries that are using the same standards. So and OpenPGP is actually used in such related products for governmental applications, and thus it's just a requirement. So not having this would have an impact. It's not just nice to have for those that that are driving these services to be want to update these services for PQC.
Sure. Yeah, I mean, I think, yeah, I mean, this is a generic issue that crops up every time we talk about what to do about curves. And it'll be the same here. I think, so at some point the working group will discuss adoption. Also, if the working group decides not to adopt it, I think a lot of the registries will be specification required. So the code points could still be arranged, even if the working group doesn't want to adopt this work, it could still get registered code points and meet people's requirements. So
Understood. Yeah. Whatever served the best, the working group the best, I do it. But right now in the draft, we only have the main requirements for the options.
Yeah.
So implementers are not required to implement all of them. They don't need to implement them if they don't need them, or they say it's not beneficial to them.
Yeah.
But there are many implementers, I believe they would be beneficial to them to at least support one of those options.
For interoperability, once there are signatures and recipients in the wild, then we may oblige implementations to adopt them all just so that they can actually interoperate, right? So we can say may, but if there's a large pool of folks who are signing with these keys, implementations that don't otherwise need it will feel the pressure to it.
But yeah, that's very correct. But that also means that their demand, when it happens, their demand for that kind of option, then their demands, you want to meet that demand or not, it's up to you.
Yep.
Okay, so so we'll get to have a discussion about adoption in the not too distant future. So yeah.
Wonderful. Yeah. Thank you.
Thank you.
Okay, thanks. Who's next? Is it Andrew or Daniel?
I think on the agenda we have Daniel next.
Okay. That is. Where's Daniel's slides? Persistent symmetry.
Yeah. He snuck in the signature salt as well.
He snuck in the signature. I'll give you control of the slides, Daniel.
Yes, thank you. Yes, so this is a short update from the interim meeting. The main thing that happened is that this draft got adopted. So that's great news. There were a few number or a small number of changes that I proposed in the interim meeting and that I made in the IETF version of the draft. If you open the slides from the meeting materials, there's a link to the diff with draft Huygens, so you can see what was changed since the call for adoption, which is I mean, sort of minor things, but not entirely inconsequential either. But the large ideas obviously the same. And I won't go through all the changes again, but you can see them there or in the slides from the interim. And if you have any feedback or questions, you can send them on the list or wherever. And then, so we have experimental implementations in OpenPGP.js and GopenPGP, but those have not been updated yet to those changes. So that should still happen. So here's just a quick reminder of the current status of the draft. Basically, it proposes two new algorithm IDs in the what is now the public key algorithm registry and would be proposed to be renamed to the persistent key algorithms registry. One is AAD for symmetrically encrypting messages or files for long-term storage and archival. And one is HMAC for storing symmetric attestations and perhaps also storing, for example, signature verification status, like I verified this signature and it was correct, things like that. And then we require these the key material for these keys to be stored AAD encrypted. If they're stored encrypted, you have to use S2K usage octet 253 is what the current draft says, and the purpose of that is that AAD binds the secret key material to the public key material, which means that they will be bound to the specific algorithm and also to the fingerprint, so you can be sure that you know a given message was encrypted with the same algorithm as that you're attempting to decrypt it with, for example. All right. So then the rest of this presentation is basically asking, like, what else should we add, if anything, in this draft? There's a few things that we could talk about that the current draft doesn't. One of them is usage guidance. So currently the draft doesn't say that much about how these algorithms should actually be used, other than, you can use them in a PKSK and in a signature packet. But we could say something like, well, if you send an email or if you create a draft, you might want to encrypt them symmetrically, although of course that's very application specific. But that's one thing we could talk about to make it easier to use, perhaps. And the other main thing in this category is, should we talk about how to indeed attest to signature verification results? As I mentioned in the beginning, you might want to store the fact that I've verified a signature, and even if, let's say, in 10 years that signature algorithm is no longer considered to be secure, you can still check the symmetric attestation, let's say, and still trust that when you receive the email, it looked to be okay, let's say. And we could, create a third-party confirmation signature for that purpose, or invent a different mechanism. But we might want to think about how to do that and then write that down. Although it's not necessarily obvious to me whether that should happen in this draft or somewhere else. But that's something we could think about. And then the other main thing in my mind is we might want to spec out the persistent symmetric key algorithm space a bit more. So one idea that I had and have mentioned on the list, but not in the draft, is that we might want to define the entire second half of the algorithm ID space as being for symmetric algorithms, which means that you can just look at the first bit and see whether it's a symmetric algorithm or not. And the benefit of that would be that for the few let's say, semantic differences that there are, you can know in advance. Like, for example, with a symmetric algorithm, you can't use the public key to encrypt, and you can't use the public key to verify, obviously. So that might be an argument for partitioning them cleanly. And then we might even want to carve out a space for experimental algorithms, symmetric experimental algorithms. For example, 200 to 210 or 228, 128 plus 100. Where we can define those, and then we might even want to put these two there for the time being while it's still draft and not an RFC yet. Although practically speaking, for existing algorithms, for existing implementations, it probably makes no difference whether we use 128 or 200, but we might still want to make changes to these algorithms, and then for testing purposes, we might want to use a different algorithm ID. So yeah, that's about it for persistent symmetric keys. So I'll pause there. So basically, yeah, the questions are: should we indeed add those things? Should we add anything else? And or you have any other feedback?
Let me ask another question to the list of questions that Daniel's raised here, which is anybody else trying to implement this, looking at it as it currently stands? We have adopted the draft. Glauco, I see you in the queue.
Yep. Thank you for the presentation. I think it's very interesting to have this feature because actually symmetric encryption is, we should not forget, PQ secure and by far more reliable than any other any conceivable public key encryption. So one thing that I remember that when I read the draft is that I think it was not accounted for that this is really used as an encryption from A to B, from Alice to Bob, and as a replacement for public key encryption. I think there was one, I'm not sure, you can correct me if I'm wrong, but I think there was one thing that was not fitting to that scenario. So, or is it, first of all, am I right in this? Do you simply mean it for the symmetric re-encryption or also for communication?
So in my mind, it's not intended for communication except as part of, well, currently it's quite common to, if you send an email to someone, to also encrypt a copy to yourself, also asymmetrically, right? And also to encrypt drafts asymmetrically, and all of that is, of course, unnecessary. So that part it's intended to replace, but it's not. I didn't have a use case in mind where you symmetrically encrypt something and then send it to someone else necessarily, if that's what you mean.
Yeah, that's what I meant. So, but wouldn't it be maybe useful if we add it in the first place, just to enable this also? Because, as I said, it's kind of a PQC algorithm. And I know that this is sometimes required. So in some scenarios, the classification level is so high that you don't rely on public key. You cannot rely on any public key scheme. And then you, well, need either a different mechanism than OpenPGP, or you need to go to password-based encryption. But I think a persistent key is much better because also then it can reside on a token, which is secured by a short pin code, a relatively short pin code. So all these advantages, it's just a replacement for public key. I mean, if we introduce it in the first place, why restrict its usage? Would you
Makes
consider
sense
this?
to me. Yeah,
I don't think you need to change
reasonable.
much. Sorry.
Yeah, sorry. I think I have a small delay, but yeah, I think that's reasonable. I mean, currently the draft doesn't say that much about intended use cases, right? But certainly we could say something about it, and then yeah, that sounds reasonable to me.
And then to the Daniel Gilmore's question: if it is if it is a communication algorithm which is PQC qualifies for PQC, we might be able to implement it as part of our project. I cannot promise it, but I would try to that we can implement this too.
Okay, Andrew, let's take the adventure of your audio.
Hi, how's my audio?
Perfect.
Okay. So, just following on from Falco's question, if we don't envisage using this for Alice to Bob communication, if we're only using this for encrypt to self or re-encryption or archival purposes or so on, is there any point supporting key distribution for this? So I'm thinking particularly about key servers, but it could equally apply to WKD. Like if we don't need to support any distribution of these public keys because they're effectively stub keys, then would it make sense if we could just filter them out completely and just not distribute them?
Yes, in fact, the current draft says that you're not allowed to create a public key with these algorithms because it doesn't really make sense. You can't do anything with them. So, I mean, obviously that's also up for debate, but to me, I agree. I don't think they're relevant to key servers.
Hi, asking as an implementer, I'm wondering whether, so we currently have this interoperability test suite, and the goal of having this specified is so you can have interoperability between two of your own clients, right? So there will need to be some form of interoperability between two clients, even if they're just controlled by the same person. And so I'm wondering actually how you see fitting this into the test suite. Are there changes that need to be made to SOP, for instance, in order to actually be able to test this across implementations?
Right, so we have a branch of SOP with a few tests, which basically just test decryption. If we want to test the full round trip, the thing that would need to change is that you would need to be able to encrypt with a private key, right? And perhaps also, well, I think you can already pass a password when encrypting, although it's intended for decrypting the signing key, right? But you might want to encrypt using a locked or an encrypted private key, and similarly also verify things using a potentially locked private key, right? So that's the main difference, both for SOP and for OpenPGP APIs in general, I would say.
If you have ideas about how to structure that for SOP, I would welcome a merge request on that document. Thanks.
Okay, don't see other questions. So I guess on this, then the draft will evolve. Bring questions to the mailing list as you think they need to be answered, and then we'll process it as usual. I'm going to suggest we switch over to Andrew now, and then we'll pop back to you, Daniel, for the SALT discussion later, if that's okay.
Thank you, Daniel.
Thank you. Replacement keys. I can give you control of the slides, Andrew.
Thank you.
Even if somebody invented them for you.
Yes, just for the purposes of everybody else's comfort, this is a small experiment in PowerPoint karaoke. So I was unavailable until just yesterday, so I didn't have time to update my slides, and DKG kindly made up some slides. So I'm not going to present DKG's slides, but drop in my own points wherever I see appropriate. So I'm going to give it a go. Excellent. Okay, that's working. Just to recap what Patrick said earlier, this was a significant topic of discussion at the recent OpenPGP email summit. And the basic idea is, can we replace human written and human readable key transition documents with something that is machine readable and automatable? The idea being that we shouldn't expect people to keep a single key forever. People will naturally get rid of keys and produce new ones, primary keys. This is over extended periods of time. So how do we manage this process of transition between one primary key and another primary key as we get new algorithms, new versions, or just new preferences, or perhaps a particular way of doing things is deprecated for whatever reason, and we need to be able to roll forwards and sometimes perhaps even roll backwards. I'm not sure what the safety complexity bullet point here is, so I'll skip it. Sorry, Daniel. So for fully automated use, we need something equivalent to a binding signature or a certification, whereby a signature by one key over another, or something cryptographically equivalent to it, allows an implementation to be able to take one key and use that to find a different key and use that key instead. So in this process, we talk about preferred and fallback keys. The preferred key will, in a typical use case, the preferred key would be, say, a V6 post-quantum key. And the fallback key will be a V4 elliptic curve key or some such. The theory behind this is that if Bob wants to find Alice's key, Bob will look up Alice's key on a key server, or he will use WKD, or perhaps pick through the autocrypt headers, or whatever the key distribution method shouldn't be that relevant. The point being that Bob finds that Alice has a new signature on her key, and based on that new self-signature, he should be able to discover another key that Alice would rather that Bob uses. And this should be possible to do completely transparently to the user. Now, once you start talking about doing things completely transparently, then you have problems like how do you prevent web bugs, or like a DOS where somebody basically creates an infinite sequence of these lookups and locks up your machine. There's all sorts of attack surfaces that you could potentially introduce. So one of the guiding principles behind this has been to try and keep it as simple as possible. So a quick list of the design goals. So the fallback certificate, which is the original key, we may want to simply soft revoke this, say, don't use this anymore, use this new key, that's all that I want you to use. Or what I would say is probably going to be the more common use case, particularly when we go to post-quantum, is we don't expire the fallback key, the original key, but we create the new key, and we have some means of saying, you may use this new key if you can support it, and I would prefer that you do, but you can continue to use the old key if that is the only thing that you support. So there is a directional relationship between these two. There's the fallback key and the preferred key, and we have in kind of like a graph theory view of things, we have directed arrows pointing between these keys. We want to be able to do this in both directions as well, because, say, for example, Bob looks up Alice's key on a key server, gets the new key, the preferred key, but say it has no usable encryption subkeys. if there is a fallback key that exists out there somewhere, then Bob should also be able to find that, even if he doesn't already have it. So we want to be able to put a pointer in both directions. So we have designed this this signature subpacket so that it can work in either a forwards or an inverse mode. And the canonical scenario will be that you would have a forwards subpacket on the fallback key pointing to the replacement key, and you would have an inverse subpacket pointing from the preferred replacement key back to the fallback key, so that it can be traversed in both directions. One of the other goals as well was that we wanted to minimize the size of the wire format, and this ruled out a couple of design possibilities straight away, because if we are talking about post-quantum keys, we don't want to be, for example, embedding an entire key that may be a post-quantum key inside a signature subpacket that may have to be generated many times as people change the preferences on their keys and have to preserve this over time. The size of the key could potentially get intractably large. So yeah, I've touched on this pretty much already. So the relationship is between the primary key and the primary key. There is no relationship between subkeys. Those subkeys are handled using subkey binding signatures as normal. This is only for changing one primary key for another primary key. So because of the two ways we want to use this, we want to use it whether the fallback key, the original key, is either revoked or not. So it can either live in the soft revocation, or if it is not revoked, it has to live in the direct key signature over the primary key. And because there is a theoretical possibility that we could use this to steal or to claim ownership of a signature made by somebody else's key, this is a similar concern that we had with subkey binding signatures over signing capable subkeys. Those require back signature. In this, we want the bidirectional signatures. Because we have a signature going in both directions, that means we need the active consent of both key holders. And if those key holders happen to be different, then one of them cannot unilaterally override the preferences of the other. So in terms of, I talked about graph theory. So in terms of the graph topology, the simple model is certificate X is the fallback key, certificate Y is the preferred key. There is a forwards relationship that targets certificate Y that is attached to certificate X, and there's a similar inverse relationship that targets certificate X but lives restored on certificate Y. And these are done using signature subpackets. Now, there are potential problems with this. The most obvious one is we can create loops. So certificate X can prefer certificate Y, which can prefer certificate Z, and so on ad infinitum. And this is one form of potential logic bomb that we want to avoid. Other logic bombs would be, say, infinitely recursing tree structures or indefinitely recursing tree structures. And in order to keep this as simple as possible, the general view amongst the implementers was that we severely restrict the graph topology that we allow. So what we're going to allow, or what we propose that we're going to allow, is that any particular certificate may have one subpacket targeting one preferred key, or it may have one subpacket targeting a list of fallback keys. So in the forwards mode, there can only be one target. In the inverse mode, there can be multiple targets, and those are ordered. The idea being that if Bob finds certificate X he can then look up certificate Y, say certificate Y does not have a usable encryption subkey. He can then, depending on the order of the inverse subpacket, he can then try certificate X, or he could potentially try certificate Z. The idea being that if Alice has multiple keys, all but the preferred key will identify the preferred key, and then the preferred key will identify a list of all of the non-preferred fallback keys. And this makes the parsing as simple as reasonably possible. The downside of this is that if you ever do change your preferred key, you have to go and update all of your fallback keys. So that is potentially a problem, but that is a problem for the key owner, whereas all of the other problems with logic bombs and so on are problems for the relying party. So on balance, we prefer to put this problem onto the key owner rather than onto the relying parties. Excuse me a second. Sorry, didn't want to deafen you there. So how is this actually done? So the subpacket contains a short header which contains a version and a list of flags and a byte. The list of flags, we only currently have two that are defined. One is that there is no replacement key, so it's an explicit null reference. And then the other one is whether this is a forwards or an inverse relationship that it represents. And then for each of the targets are represented by three fields. The first field is the version of the primary key of the target, so say version 4 or version 6. That will then tell you the length of the next field, which is the fingerprint of the target. So these two fields they're exactly the same as we use in the intended recipient fingerprint subpacket and the issuer fingerprint subpacket, version plus fingerprint. But we also add a third field, which we call the imprint. And this is inspired slightly by the proposal for first-party attested third-party certifications, which use not the fingerprint hashing algorithm of the target key, but the hashing algorithm that is used in the signature that this subpacket is contained within. The reason for that is to make sure that the reference to the target is always at least as strong as the entire signature that it is in. Because one of the potential issues with a model like this would be you could have a SHA-2 or SHA-3 signature containing a subpacket that refers to a SHA-1 version 4 fingerprint, which would reduce the cryptographic strength of the binding. So the idea is that whatever hash you use for the enclosing signature, you must also use in the identification. So we use both the fingerprint and the imprint because we still need the fingerprint to be able to do a network lookup. So if you want to look this target key up on a key server, you still need to do it by fingerprint. The reason for that is that the imprint will depend on the hash algorithm that the imprint uses is context dependent, so it is not a stable identifier. So you cannot use it for a network-based lookup. So one gives you the stable identifier and the other one gives you the cryptographic strength. So we use both of them. This increases the size of the packet a bit. And for example, if the fingerprint hash algorithm is the same as the signature hash algorithm that's used for the imprint, then you're essentially putting the same field in twice. But it's in the big scheme of things, that's quite a small price to pay, we believe. There are a couple of potential wrinkles with this, but I don't think they're insurmountable. One of them is that if you are using partial weights in the web of trust, you have to be careful about the the weight that you assign to replacement keys. If you have a bunch of keys that are all equivalent to each other, you shouldn't really count them as multiple keys in terms of the web of trust for calculating partial trust weights, because then somebody can game the system. The other thing is that these equivalent groups, because people are making these signatures and overriding the self-signatures, these equivalent groups will change over time. So the question probably for a higher level is, how do you maintain these? Do you maintain a state history of these when you're trying to, say, verify historical signatures? And yeah, the issue about the transitivity, the relying party always needs to understand the preferred primary key. And if that is, for example, a post-quantum signature algorithm, then the fallback mechanism doesn't work. So these are some slight shortcomings that we do need to be aware of. So Andrew will post draft IETF soon. I actually did it this morning. It's waiting for chair approval. There is a reference to the previous version of the draft in the meeting agenda. There is very little change between the previous draft and the upcoming one. The only differences are some editorial changes that Falco mentioned to me on the list a couple of weeks ago. So feedback, please, questions, please, and some indication of whether people are going to be implementing it soon, or whether people would be willing to implement, would be very, very helpful. Thank you very much.
Thank you, Andrew. Do folks have questions? There were a couple things that came through in the chat. I don't know, Mike or Eustace, if you want to raise those, or anyone else.
Yes, it seems to me that you're adding a lot of complexity for aligning the graphic strength with the SHA-1. I mean, yeah, SHA-1 needs to go and V4 needs to go, but the second pre-image resistance of SHA-1 is not in question, is it, right? And that's what's important.
It is not in question at the moment, no. The question here is whether we can define a generic mechanism. So this is not specifically targeting SHA-1, although SHA-1 is potentially a minor concern, but there may be issues in the future with other hashing algorithms, and we want to be able to handle any issue that might arise in the future. So yes, this is a very conservative design. It's slightly over-engineered, but we preferred slightly over-engineering if that gave us the ability to have a completely generic mechanism.
But we are only talking about the strength of the hash algorithm we use to produce fingerprints, and if that
Correct.
falls, you're saying SHA-2 will fall one day before we moved on, then we've got other problems, don't we?
Yeah, potentially. Again, this is very much belt and braces. It is absolutely belt and braces, and I agree with you. There is redundancy in it, but this is erring on the side of caution.
Well, that's not free. Anyway, let's take it off.
No, it's not, absolutely not. Everything, excess caution and redundancy does come at a price. Absolutely. Yeah.
So, I mean, this is a working group draft. So the working group can say we have a consensus to make changes to it too, right? In its current form, it's now draft IETF. Thank you, Stephen, for hitting the OK button. But this is something that we can make a decision on as a working group about whether we need this conservatism or not. Right. Speaking of conservatism, I also noticed that there is a version number in the sub packet. Can you explain why we need that, Andrew? Or I might see what the working group says.
So the version number in the sub packet. So I think historically there have been a few instances of sub packets being defined with version numbers in them. I'm agnostic about whether it is required. So I personally will go with the working group. If the working group is happy to leave this version number out and use a different code point for any updated packet format in the future, I personally wouldn't have a problem with that.
So, I mean, I guess I have a chair-like question. Given that this was mentioned as a kind of migration tool in Patrick's early discussion, what do we think is the best way for kind of progressing with this? To obviously we have made this discussion, but have an interim meeting at some point on this topic. I don't know what people think is the best way to progress it. It might be that, you know, having an interim meeting where people discuss this in the next few months is sensible. So I just want to see if people think that that would be the case, or if that's a stupid idea. So Andrew, what do you think?
I'll let Aaron go first.
Okay.
Hi. I am heavily biased clearly on this topic, but I really like the idea of having a discussion specifically onto how to allow a smooth V6 migration. This was also one of the points I had in the slides before. Many people are not willing to have the binding if there is not such a thing defined beforehand. So having an interim meeting in between the two IETFs where we tackle this point is, for me, thumbs up.
Yeah, I would be happy to do that. You know, we need to fill out. At the moment, the draft is quite technical in terms of the wire format, but it would benefit from a lot more higher level context, and yeah, I think a meeting would be useful for that.
I will try to schedule a meeting probably for sometime in September. So you will see a note about that on the list soon. And please, when you see the scheduler, let us know your availability.
Thank you.
Thanks, Andrew. And thanks for being available and dealing with slides. Surprises. Okay, so I think we have one more topic, which was...
Yeah, Daniel, you want to bring back the SALT discussion?
And just so people know, as DKG said at the beginning, we have stickers. I put some of them down at the back there by the water thing, so you can grab those on your way out if you like stickers. Meanwhile, so the SALT non-working group draft is something that somebody might want to propose. So let me give you control.
Yes.
Okay, so we got like 12 minutes, Daniel. So I don't think we have any other business after this. So go ahead.
Great, thanks. Yeah, so before I say anything else, I have to say that this is not based on my idea. This is, credit goes to Sequoia for implementing and coming up with the idea of having a signature salt notation. But that being said, yeah. So what is the idea here? We added a salt to v6 signatures for a couple different reasons. One of them is to hedge against hash algorithms being compromised, especially chosen prefix attacks. And another is to protect against fault attacks in deterministic signing algorithms such as EDDSA. And basically the idea here is that, we might want to do something for for v4 signatures as well, for the during the time that we still have to create them in some scenarios where v6 is not fully rolled out or supported yet. So the basic idea is to create a signature notation with a random salt in it, which is perfectly backwards compatible as long as the notation is not marked as critical. All implementations should, and as far as I know, do just ignore it. So that's a safe place to put some random data. And the length in the draft is dependent on hash algorithm, same as for v6 signature. So this is unlike Sequoia's implementation, which is a hard-coded 32 octets, but okay, it's a minor difference. So yeah, as I said, the main security advantage of this is to protect against fault attacks. Basically, if you sign the same thing twice with EDDSA and you accidentally, or if an attacker is able to introduce a fault in one of the in the signing process during one of them, you might leak something about the private key material, or the attacker might be able to learn something about the private key material. So the idea here is to basically never sign the same thing using EDDSA, and by always having a salt somewhere in the input to the hash, which becomes the input to EDDSA, right? So on the downside, unlike v6 signature salting, it doesn't necessarily protect against common prefix attacks, because the notations go after the message data in the input to the hash. So I should also make it clear that none of this is intended to replace v6 or somehow slow down or make it unnecessary to deploy v6. That's not the intention. We should still deploy v6, obviously, but for the time being, while we still create v4 signatures as well, this is sort of a stopgap in the sense of better than nothing, so to speak. So yeah, the current status is obviously Sequoia implemented with the notation name salt at notations.sequoiapgp.org, openpgp.js v6, and now GopenPGP v3. Copy it with our own notation name, basically because it didn't occur to us that we could reuse theirs, but DKG pointed out on the list that we could have done that, which is of course true. But so that's what we have for now, and there it depends on the hash algorithm as well, the length. And what this draft basically says is, we could just register salt by itself in the IANA registry, so that we don't have to use these long notation names with a domain in them. So yeah, that's about it. So I guess is there any feedback and or other thoughts? And is this something that the working group feels that we should adopt?
So I had a question about the binding it to the hash algorithm length. That makes sense if I'm generating it, but I don't understand what to do if I receive it and it doesn't match. Are we saying that like this invalidates a signature if you know about this, or is it like what is that binding between the hash algorithm and the salt length mean?
Yeah, that's a good question. The current draft doesn't really say much about it. Mostly, I just copied that from the V6 signature salting. So I would kind of propose that we do the same thing as there, but I'm open to thoughts.
So if we do the same thing, then implementations that don't know about this will accept a signature that implementations that do know about it will reject. That seems a little bit strange to me.
Right. Yeah, perhaps we should accept anything. I'm not sure.
Okay, so we don't have anybody else in the queue here. So I guess there has been some discussion on the list about this. I suspect we should let that discussion continue, and we'll see where it lands. If it lands on an adoption call, or if it lands on some other place. So I think we just continue discussion on the list, I think is the outcome here. Okay.
That's good. Thanks.
And I think that's more or less us.
Yep. Just on any other business.
We're on any other business? Does anybody have other business? If not, then thank you. And like we said, we'll probably have an interim meeting about the replacement stuff in the coming months, and the post-quantum and other work is going to progress and will be discussed, I guess, in November when you're all coming to Dublin, I hope. So I'll see you there.
Thanks, everyone. Thank you to our presenters.
If you want stickers, they're up at the front, or grab some at the back there. Take as many as you like. Thank you.
All right. First session complete.
Yes. Oh, it's nearly done, huh?
What's that?
Oh, nearly done. But,
part of me wants to adopt that draft so we can just say we processed the draft. The salt.
But then, yeah.
I mean, there's the amount of.
Well, I mean,
like
protecting against
low.
fault attacks is not trivial, right? So, I mean, if people can inject faults, I mean, I'd love to see a